This is geometry topic 3. Topic 3, transformations. In this topic, we are going to think about the properties of the 4 types of rigid motion. What are the properties of the 4 types of rigid motion? Topic 3 begins by focusing on transformations, moving from the definition of rigid motion to the rigid transformations. Reflections, translations, and rotations. The rest of the topic examines how transformations can be combined to create new images and complete proofs, such as the proof for demonstrating that a composition of 2 or more rigid motions is also a rigid motion. Okay. We have 5 lessons total in this topic. And 6 new vocabularies: composition of rigid motions, glide reflection, point symmetry, reflectional symmetry. Okay. So you would probably watch the STEM video in class. Okay. 3-1 is about reflections. In this lesson, you will be able to find a reflected image and write a rule for a reflection. You will also define reflection as a transformation across a line of reflection with given properties and perform reflections on and off a coordinate grid. Okay. The vocabulary: rigid motion is very important. Let's look at explore and reason. The illustration shows irregular pentagon-shaped tiles covering a floor. Okay. Part A. Which tiles are copies of tile 1? Look at this tile 1. It's the blue shaded pentagon. If you look at tile 1, it is filled with blue. So if you look at other tiles that are blue, are they really the same or are they not? Not only does the color has to match, right? You can also look at the shapes and the sides and their orientation. Okay. Is yellow 1 a copy of 1, disregarding the fact that it's a different color? Just look at the shape. Yes, they would be the exact copy, but what's different about them? They're flipped, aren't they? It's almost like they're reflected across the line that they meet, right? So the beige tiles are mirror images of the blue tiles. Let's write that down. Okay. If you were to move tile 1 from the design, what actions would you have to do so it completely covers tile 2? So it completely covers tile 2. Reflection. You could slide, turn, and flip, right? So those are the actions that you know. Flip it, make a reflection out of it. Okay. Which tiles are not copies of tile 1? Okay. Or if you look at other tiles, which tiles are not copies of tile 1? Can you see any tiles that are not copies of tile 1? Well, you could say they're all copies of tile 1, but the beige, the yellow tiles are more like the mirrors. They're not exact copy, like copy and paste, the same thing, right? They're reflected. So you could say that they're a little bit different. Are the mirror images of tile 1. Okay. So in this lesson, think about this essential question: how are the properties of reflection used to transform a figure? Look at example 1. Identify rigid motions. A rigid motion is a transformation that preserves length, very important, and angle measure. It preserves length and angle measure. It's a transformation of rigid motion. So check if it preserves length and angle measure. If it is, it's a rigid motion. Look at the pre-image. Pre-image to image. Does it preserve length? Look at their corresponding sides. This is, let's say, side 1, side 2, and then side 3. Are they the same length? No, so you cannot say they're the same length, which means they do not preserve length. Angle measure, sure, they could have the same angles, right? Seems like they have the same angles, but do they preserve length? No. So although angle measure is preserved, the image is smaller than the pre-image. So the transformation involves change in length, which is not a rigid motion. Okay, rigid motion has to preserve both length and angle measure. Let's try number 1, A and B. Look at the pre-image and image here. Are they a rigid motion? Look at the pre-image and image. Do they preserve length and angle measures? Do they have the same shape? So look at the angles. Are they the same? Yes, they look the same. The measure, you can look at your tape measure and or a ruler. You can use your ruler to measure them. They will be exact same length. Wait, that's 2. That's 1. That's 1, 2, 3, 4. Okay. There you go. So yes, this is a rigid motion. The points of image are in reverse order, so it's like a reflection. But the length and angle measure are preserved. So it is a rigid motion. Okay, part B. Are they the same length? No, this is not a rigid motion because the size of the image changes. So the length measure is not preserved. Okay. Page 106. Okay, this is reflection. This is how reflection is defined. A reflection is a transformation that reflects each point in the pre-image across a line of reflection. There's a line of reflection where you're reflecting it from. A reflection has these properties. First, if a point A is on line M, if a point is on the line that's reflected, then the point and its image are the same point. If it's exactly on the line of reflection, the point is reflected by itself, to itself, okay? If a point B is not on line M, the line M is a perpendicular bisector of B to B prime, okay? So if you draw a line that's perpendicular to the line of reflection, it should be the same distance away from your image. the image point. Okay, the reflection of triangle ABC across line M can be written as R sub M parentheses triangle ABC is equal to triangle A prime, B prime, C prime. Okay, whatever point that's after the reflection or any transformation will be notated as prime. Okay, so that's the notation for the image. This is the pre-image, the original shape. A reflection is a rigid motion, so length and angle measures are preserved. Okay, it's a type of rigid motion. Look at example 2. Reflect a figure across a line. How can you reflect triangle FGH across line L? Okay, this is a line of reflection. You should reflect across line L. So what's the definition? If you draw a line between the pre-image points to image points, they should be perpendicular and you should have the same distance away from line L. So draw a perpendicular line, right? And then you're going to draw another line that's the same length and distance away from that line L, which is also perpendicular. So that's going to be H prime. Same thing for G. Perpendicular, perpendicular, G prime. F, perpendicular, perpendicular, F prime. Okay? And then you connect the points, and that's your image. H prime, G prime, F prime. Okay? Type 2, what's the reflection of triangle LMN across line N? Draw your reflection across line N using the steps we went through in example 2. See if you can get it by yourself. Come back when you're ready. Okay, there. Draw a line perpendicular to line N. Keep going. The same distance away from line N should be your point of reflection. Example 3, reflect the figure on a coordinate plane. Quadrilateral FGHJ has coordinates 0, 3, 2, 4, 4, 2, and -2, 0. So now looking at the coordinate plane, can you find the specific exact points for the reflection of FGHJ? If you're reflecting a point across the x-axis, it means you need to draw a line perpendicular to x, which is a vertical line. And it needs to be the same distance away from the x-axis, right? So 4, 2 is 2 units away from the x-axis, which means you need to go further down 2 units further. So that's going to be same x, but different y value. How are the y values related? They are the opposites. 3 and -3, 4 and -4, 2 and -2, and 0 is opposite to itself. So when you're reflecting points across the x-axis, your x values stay the same. But notice that your y values become the opposites. So those are going to be your new points. Okay. Part B. You have FGHJ, which is a shape that goes across the y-axis, and you want to reflect across the y-axis. What about the point over here, J? Same thing. You do the same thing. You have to draw a perpendicular line to the y-axis. Same distance away on the other side would be your point of reflection. So -2, 0 becomes, that's 2 units away. 2 units to the right would be your new point, 2, 0. So what happens to the points when you reflect across the y-axis now? You have the same y values, but your x values are the opposites. See? 4 are the same, 2 and -2 are the opposites. 2 are the same. 4 and -4 are the opposites. And point F is exactly on point and on the line of reflection. So it stays right where it is, 0, 3. Okay, that does not change. All right, let's look at 3A and B. Reflect this triangle ABC across x-axis and the y-axis. Remember the notation? This means reflect across the x-axis and reflect across the y-axis. Find out the coordinate points after your reflections. Come back when you're ready. All right, part A. First, you want to graph the pre-image. 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, 6. Sorry, it's a little bit crooked. That's our point A. Point B, 1, comma, -2. C, -1, 2, 3, comma, -1, 2, 3, 4. Right here. Okay. So it goes over your x and y axis, right? What are the coordinates of the vertices? When you reflect across x-axis, this is x, right? So then your C is -3, comma, -4. When you reflect across the x-axis, which values change? Do you remember? X stays the same, the y is gonna change. So to the opposite, right? So x is still -3. So C prime should be -3, comma, opposite of -4 is +4, okay? B prime, same x, opposite of -2 is +2. A prime, same x, -5, opposite of +6 is -6, all right? So that should be your coordinate points for your reflection of the triangle on the x-axis. In the same way, y-axis would be same y value, the opposite x values. So you have 5, comma 6, -1, comma -2, and 3, comma -4. Okay. All right, reflecting points across the x and y axis. When any point, x, comma y, on the coordinate plane is reflected across the x-axis, its image should be x, comma -y. Your x is still x, but your y value becomes -y, which means the opposite, right? Same thing for the y-axis, but in the reverse order. So when any point P, x, comma y, on the coordinate plane is reflected across the y-axis, its image should be -x, comma y. Let's look at example 4. Describe a reflection on the coordinate plane. What reflection maps triangle KLM to its image? Write the coordinates of the pre-image and the image, and then you're going to find the midpoints and figure out the points. We got 1, comma 1. Okay, that's 1 point. And then we got -2, comma -2. That's another point. If you figure out the midpoints, that should be exactly on the line of reflection. Why? Because the distances between 2 points should be exactly the same from the line of reflection, right? So you get the midpoints. Those 2 points should be your points on the line of reflection, right? Do you know how to write the equation of the line using 2 points? Using 2 points, first you figure out the slope. Your slope equation, change in y over change in x. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Plugging in that, you should get slope is 1. Okay, and then you can use point slope form or slope intercept form, whatever you please. But if you have a point already, it's easier to write an equation using point slope form. So plug your point slope form to refresh your memory. Looks like this. Okay, so put in slope here and then put in your x and y values in these two value places. Okay, you can choose any point. It does not change your equation. You can choose 1, 1 and say y minus 1 is equal to 1 times x minus 1. And your equation should be y equals x. Okay, if you simplify it. And that's also Sylvain's form. So your transformation for this one is a reflection across the line y equals x. Okay, you do not have to have reflection on the x or y axis all the time. You have numerous lines of reflections depending on what your line is, right? So in this case, you're reflecting your image on your pre-image on y equals x line. That is your line of reflection. So try number 4. You're finding out the equation of the line of reflection. Figure out the midpoint. That's your first step. Figure out the slope. Write the equation using Poincare form. Simplify your equation. That should be your equation of line of reflection. Okay, come back when you're ready. All right, looking at part A. Figure out the midpoint between C and C prime. Your midpoint should be your x values added up together divided by 2, comma, your y values added up together divided by 2. So then you have negative 5 over 2, comma, 5 over 2, right? That should be your midpoint, one midpoint. What about D? 5 minus 12 over 2, comma 12 minus 5 over 2. That should be 7 over 2 and 7 over 2. Oh, that's negative 7 over 2 and 7 over 2. So you already have 2 points now. I know they're fractions, but that's okay. You can still use the same steps. Figure out the slopes using the slope formula. 7 over 2, that's y sub 2, minus 5 over 2 over negative 7 over 2 minus negative 5 over 2. Okay, then this is your slope. Okay, so you can say 7 minus 5 is 2. 2 over 2 over 7 plus 5, negative 7 plus 5 is negative 2 over 2. Okay, so that's 1 over negative 1, which is negative 1. Your slope is negative 1. Your equation should be y equals, or use the Poincare form, pick a point. Pick any point of the midpoint, okay? Y minus 5 over 2 equals your slope times x plus 5 over 2, or x minus negative 5 over 2, okay? And then if you simplify that, it becomes y equals negative 1 or negative x minus 5 over 2, right? If you do the distributive property, plus 5 over 2, that just becomes y equals negative x. So part A is a reflection across y equals negative x line, okay? Or you can abbreviate to say R, y equals negative x, okay? Part B, in the same way, your answer should be reflection across x equals 1, okay? How do you know? Do you want the steps? Yes. Let's figure out some midpoints, okay? Midpoints for f and f prime. 7 minus 5 over 2, 6 plus 6 over 2 should be 1 point. So that's 2 over 2, which is 1, comma, 12 over 2 is 6, 1 comma 6, that's 1 point, okay, midpoint. And then let's do G. 0 plus negative 5 over 2, then negative 4 plus 6, wait, is that right? Negative 2, no. I looked at different points. Be very careful to look at the same points. G and G prime, 0 and 2, 2 over 2, okay? And then negative 4 minus 4 over 2, that's 1 comma -8/2, which is -4. Okay. Wait, is that one? Yes. 0 and 2. Yes. Okay. So we got 2 points. 1 and 6, 1 and -4. Find the slope for that. Okay, 6 minus -4 and 1 minus 1. That's 6 plus 4 divided by 0. What is that? Undefined slope. What does undefined slope do? It's a vertical line. Okay? But still, you can write an equation. Your equation is going to be, for vertical lines, it's always going to be x equals a number. So look at your x value. That's equal to 1. So your x should be 1. And that has a slope of undefined slope. Okay, that's why you have a reflection across x equals 1. Right? Let's look at example 5. Okay? In a billiards game, a player must hit the white cue ball so that the cue ball hits the red ball without touching the yellow ball. Where should the cue ball bounce off the top rail so that it hits the red ball? Okay, the cue ball is this white one. You're trying to hit it so that it hits the red ball without touching the yellow ball. So you don't want to hit like this. You might want to hit it like this so that it angles off so that it reflects across your line R over here. And then it angles it just right so that it hits this red ball. Okay? Consider the top rail as a line of reflection and find the reflection of the red ball. So you want the same distance away from your line of reflection. And it's going to be the same angle, right? So draw a segment from the cue ball to the image of the red ball, which is going to be O prime right here. That is your image for the line of reflection, okay? And then the line of reflection is drawn where the cue ball will bounce. So reflect the segment from the cue ball to the red ball across the line of reflection so that, right? So that you know the angle exactly, the point where it exactly hits the line of reflection, right? So think about the reflection right here. It should be the same distance. And if you are aiming to hit a ball that's over here, which is outside the table, you should get a straight line and it should be the same angle from the reflection to where the ball is going. Okay, the player should aim at point P over here where the two segments intersect. Okay, what do you notice about the angles formed by the line of reflection in the path of the cue ball? Why does this make sense? Which are congruent? Okay. The actual image is reflected across the line of reflection formed by the mirror, right? It's outside over here. You're imagining it. This distance away from the mirror is the same. That's the same as this one. At the distance the image appears to be. So if you're aiming for this image, you get a straight line aiming for that, which should give you the same force to reflect at the same angle to hit the print image. Okay, so this type of problem is a real world example to where you can use the concept of reflection. Let's look at try number 5. Student A sees the reflected image across the mirror of another student who appears to be at B prime. Trace the diagram and show the actual position of student B. Notice that this is B prime, which is probably reflected across the mirror, right? So from student A's view, he's over here. So where is he actually? That's a mirror image. So you want to draw the same perpendicular line across the mirror that is the same distance away from the mirror, which is about here. Wait, is that too far? Okay. It's about here. Okay, that's gonna be not B prime, it's gonna be the B. All right. Okay, let's summarize our lesson. Concept summary reflections. A reflection is what? It's a type of transformation that reflects each point in the pre-image across a line of reflection. So if you look at the diagram, you see some points for a triangle ABC. If the point is exactly on the line of reflection, it's reflected to itself, so it doesn't move. But if points are not on the line of reflection, you can draw a perpendicular line across with the same distance on the other side to graph the image of your per image points. Okay, so if you look at the symbols, capital letter R will represent the transformation of reflection. And whatever sub value you plug in will be your line where you're reflecting your images by. Okay. All right, that was lesson 3-1, reflections. We'll continue on with other types of transformations in the next lessons. Bye.